A single cylinder two stroke high speed diesel engine working on dual cycle has a compression ratio 15:1. The engine takes in atmospheric air at 1 bar and 27 degrees Celsius. The maximum temperature in the cylinder is 1312 Kelvin. The cutoff ratio is 1.093. The engine has a bore of 200 mm and stroke length of 250 mm. The engine speed is 3000 rpm. Calculate the following: 1. The cycle efficiency. 2. The net work output per unit mass of air. 3. The power output. 4. The mean effective pressure. 5. The ratio of heat added in constant pressure to that in constant volume process. Draw PV and TS diagram of the cycle. For air, gamma is equal to 1.4, R is equal to 0.287 kilojoule per kilogram per degree Kelvin. So here this is your PV diagram of dual cycle. 1, 2 is isentropic compression, 2, 3 is constant volume heat addition, 3, 4 is constant pressure heat addition, and this is isentropic expansion, and this is your constant volume expansion. And compression ratio R is equal to V1 by V2 is given as 15. Okay, this is your compression ratio, total volume by clearance volume, and P1 is given as 1 bar and T1 is given as 27 joules. So at the inlet the temperature is 1 bar, pressure is 1 bar and temperature is 27 joules Celsius or 300 Kelvin. And maximum temperature in the cycle is given as 1312. So that is the maximum temperature, T4. And cutoff ratio is given as 1.093. So V4 by V3 is the cutoff ratio. Diameter is 200 mm and stroke length is 250 mm. Engine speed is 3000 rpm. For process 1, 2, which is your isentropic process, we can use isentropic relationship. So V1 by V2 raised power gamma minus 1 will be equal to T2 by T1. So this is your V1 and this is V2. So V1 by V2 is your 15 and gamma minus 1 is 0.4. So T1 is 300. So T2 will come out as 886.253 Kelvin. So now if we consider because we have temperature at 4, so we can and this process is constant pressure process, so we can find out T3 from it, because V4 by V3 is known, that is your cutoff ratio, and T4 is known. So and the process is constant pressure process using state relation P4 V4 by T4 is equal to P3 V3 by T2. P3 and P4 are same. So T3 will be equal to V3 by V4 into T4 or T4 by 1.093, because V4 by V3 is 1.093. So T3 will come out as 1200.36 Kelvin. So now process 4, 5 is your constant volume process, sorry, isentropic process. This 4, 5 is isentropic expansion, and V4 by V3 is known, that is given 1.093, and V1 by V2 is also given, that is 50 compression ratio. So from this V1 is equal to V5, because phi 1 is your constant volume process and V2 is equal to V3, because 2, 3 is your constant volume process. So V5 by V3 is also equal to 50. So from V5 by V3 and from V4 by V3 we can find out V5 by V4. So that is 15 by 1.093, that is 13.7236. So volume ratio is V5 by V4 is 13.7236, and we have temperature at 4, that is maximum temperature 1312, and we have now V5 by V4. We can use isentropic relationship and can find out T5, that is 460.11199 Kelvin. Okay, so now first part is to find out cycle efficiency. So first we find out second part, then we find out first part. So second part is net work done per unit mass. So work done in cycle is heat supplied minus heat rejected. So heat supplied is into processes. Heat is supplied into processes constant pressure process and constant volume process. That is Cp T4 minus T3 plus Cv T3 minus T2, and heat rejected is Cv T5 minus T1. So putting we have all the values. T4 we have, T3 we have, T3 we have, T2 we have, T5 we have, T1 we have, and Cp and Cv are 1.005 and 0.05. From this we get the work done per or net work done per unit mass is 223.01412 kilojoule per kg. Now heat supplied is this part. So this part comes out as 338.3574. Okay, so now efficiency is work done by heat supply, so that is 65.91%. And mass intake per second is, because this is the volume intake of, you can say, swept volume, and P1 is pressure, T1 is temperature, R is characteristic gas constant, M is per unit. This will be a per cycle mass intake per cycle. If you multiply it by N by 60, then it will be mass per second. So that P1 value is 1 bar, that is 1 into 10 to 5, and this is swept volume, that is by the 4.2 square into 0.25, and this is 3000. This is 3000, this is 27, and this is 300. So mass intake per second is 0.455865 kilogram per second. Okay, and the power dot is mass into work done per unit mass. So that is 101.66 kilowatt. And the mean effective pressure is powered work divided by swept volume per second. Swept volume per second we have to here also. So it will come out as 259017 Pascal or 2.59017 ampere. Next part is to find out the ratio of heat supplied at constant pressure to heat supplied at constant volume. That is Cp T4 minus T3 divided by Cv T3 minus T2. So putting the value of Cp and T2 by Cv as 1.4 and values of T4, T3 and T2, we can get this ratio, that is 0.497.